Hello and welcome to Southwestern Unit 3, and this is specifically involving, well, I should say Chapter 3, Unit 2. And it specifically involves some table creation. And what I did was, there's a number, the first 17 slides in this particular chapter is specifically geared towards starting up the program and things along those lines. And what I wanted to do is I wanted to talk through some of the elements specifically involving creating of the table and what you're looking at and how that's actually interpreted. For instance, you have the creating a table, and this is create table rep, right? And what this does is this defines the elements in create table, and this means that rep number, what is a primary key, and it consists of 2 characters. Last name doesn't say anything, it's character, 15 characters, da 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 da. So it's all a character value, so it's creating columns that look similar to this, and I'm just going to pull it up in Excel to give you a general idea. So I'm actually creating a rep num field, and it's going to be too long, right? And then there's a last. You'll notice the naming conventions, I'm not putting any spaces in it, and it's a character data type of 15 long. And then, it just kind of continues from there. But what's interesting is that rate is declared as a decimal, right? So here's rate, and it's declared as a decimal. And this represents the number of numbers, and this represents the precision, or how many decimal points there are. So in this particular thing, rate can only end up being a number that looks similar to this, as if those were numbers. So if I wanted to give examples, it could be 1.12, it could be 1.34, it could be 5.67, but in each one of those cases, there are 3 total decimals and 2 digits, there are 3 total digits, 2 behind the decimal. So I guess the way that it might look is something like this would be more accurate if it's stored this particular way. So that would be a 97% rate. This would be a 3% rate. More than likely, this is the way the rate's stored as opposed to this, but it might be too early to determine, but at least you kind of understand. Whereas the commission is notice it is 7 digits, 2 decimals. So it could be up to 7 digits long, including the 2 decimals, and that's important there. So this can be up to 3 digits long, including the 2 decimals. 3 digits, including the 2 decimals. So something to keep in mind as we go through. So as we go about creating the table, it says, describe the layout of each table in the database. Use create table command. So here's our create table command. Table is followed by the table name. So create table, which is our table command, and then create table, and then rep. So rep is the actual name of the table itself. And then it defines all the elements that are part of the rep table that starts with this parenthesis and ends with this parenthesis here, and it ends with a semicolon, meaning I'm done creating the elements of the table. It says follow this with names and data types, right? Data types define types and size of the data, and we'll talk more about that. You'll notice that when we actually create the table, there's going to be some column and or name restrictions. Names cannot exceed 30 characters in length, must start with a letter, and can contain letters, numbers, and underscores, and cannot contain spaces. So when I look at these, notice there's no spaces in the name, city, street. If it's a dual name, it's first underscore name, meaning it's kind of put together so they're they work together, last underscore name. So in each one of these cases, it has to conform to these naming conventions where it says contain letters and cannot contain spaces. So kind of let's continue here. Let's see. It says commands are free format, no rules stating specific words in specific positions. Indicate the end of a command by typing a semicolon. Commands are not case sensitive. In Oracle, enter the commands in SQL Editor pane. So we're going to, and this is actually entering of the command where here's my create table rep, all the elements. It indicates that the rep number is a primary key. And remember, a primary key means it cannot it cannot repeat. So if we have a rep number that's 75, there won't be any more rep numbers that are 75. And it actually once you're all done with this, you can save it, and also you can run it. When you run it, it creates this particular table. We haven't put any data in it, but that table is actually created. So let's kind of continue from there. So command completed successfully, meaning it actually runs this SQL very successfully in creating that particular table. We're awesome. So correcting errors in SQL, use the same techniques that you might use in a word processor. Make changes and click run. Okay, not a big surprise there in any way, shape, or form. Let me kind of move this forward a little bit more. If you can correct the errors by dropping the table and then starting it over, so you can delete the table itself. So if you create the table, then discover there's errors, it's better to just delete the table, make the changes, and then recreate the table itself. You have to remember that if you actually delete the table itself, any data can also be deleted. Now, when you get into working with data types, and I've done some things here in reference to data types to give you some idea, this defines the type of data that's actually entered in that particular SQL statement. So for instance, decimal P and Q. P is precision, Q is scale, right? Use something like decimal 18.4 instead, but this gives you a total of 18 digits, 4 of which after the decimal point. So, and 14 before the decimal point. So you'll note that this represents right here, because this is just an example I pulled out. This represents a number of digits. This represents a number of digits. This represents the actual precision as far as, this represents the number of digits that are behind the decimal point. So there's 18 possible values, 4 of which can be behind the decimal point. It gives you a total of 18 digits, 4 of which after the decimal point. There's char n, right? And char n, which is right here, okay? And what that does is that gives you a fixed length non-Unicode string data. N defines a string length and must be a value from 1 through 8,000. The specific thing is if you declare char to be 15, it has to take up 15 elements. So if I put in a name there that's 10, then the other 15 elements will be blank, but it does always equal that 15 element. The deal with varchar is that if you declare it to be 15 long, it'll only use what's necessary. So if a name is entered that says it only has 3 elements to it, it's only going to use those 3 elements and not fill up to the 15. So it kind of goes back and forth between it. It says so it can grow and shrink as needed. It slows down searches. The difference between char and varchar is that the varchar, because it has that variable length, can slow down searches, whereas char has a very, very specific number. And it also goes into, well, date obviously stores a date, decimal we talked about, and then there's int and small int. Now, in reference to any of these integer values, here's 4 of them, 1, 2, 3, 4. You'll notice that it gives a range of numbers that is fairly huge, usually from a negative number to a much larger, like there's a negative 32,768, larger 32,767. So it'll depend on what number that you expect to actually be entered in. However, the one thing you have to think about is in reference to storage. So if you only have, let's say, 1,000 records you're dealing with, the size of the data type that you use might not be that important. But if you have the ability to expand later on and it's going to gain more size as you go through, yeah, that's very important. You're going to have to make that consideration. If that number will never get close to a 2 billion time frame, maybe, you know, it's good to normal int. If it gets huge, maybe a big int is important. So those are the type of things or questions you need to ask yourself as you go through and work with these items. And that pretty much works with our using data type. Now, the idea behind a null, or any null, is a special value represents a situation where the actual value is not known for a column. Can specify whether to allow nulls in individual columns. And what it is, for instance, if I was going to come up with a rep number, as an example, and a rep number is a pretty unique number, I would not want the rep number to be null because it wouldn't make any sense. Let's say I didn't know the address at the point in time where I entered in values. If I go back to my, this example is great. Obviously, the rep num is a primary key. It's automatically flagged not to be null. The last name and first name also automatically flagged not to be null. So I can enter in these rep information, and then, for instance, the street, city, state, postal code, commission decimal, and rate decimal aren't, there's not a requirement for them to be null, though the decimal and the rate decimal will yearn for an actual number entry. The last name and first name are required. So literally that record cannot be entered unless it actually has a value for those two particular elements. So once we've established that we create a table and we establish some sort of criteria for entering in data, making sure they can enter in data only if it fits that certain criteria. You have a last name and your first name, and then you have a primary key. The next thing we're going to do is we're going to actually insert data into the table. So the first step, we've created a table. The second step, we're actually inserting data into the table. Now, when working with any database management system and working with any database at all, your table design is almost the most crucial, because that's your bottom basement level of getting information from it. So if your table isn't created correctly, if you do not have the right information that establishes that, it's going to come back to haunt you. So you need to make sure to take that time to do what you're trying to do correctly. Alright, so let's take a look here. So here's our insert into rep values. This actually creates, now this already makes the assumption that you have created a rep table. From here, what you do is you're inserting those values, and in my case it does 15 Campos, Raphael, 724, and so what it's doing is it's going through after we've created it and inserting the values between the apostrophes that indicate that they are indeed going to be put into that table. You'll notice over here where it says 0.06, that's our commission rate that we talked about earlier. And this particular one, let me see if I can get our commission tables right here. And let me take a let me snag this real quick. And it kind of makes it a little bit easier to look at when you're looking at them side by side. Where did I do it? Oh, there we go. So now I've created the table, right? And my table is, there's my rep number, which is 15, last name, which is Campos, first name, which is Raphael, and then the street name, which is 724 Vinca Drive, right there. And then the city, switch it over here. The city is Grove. The state is California. The postal code is 90092. The commission decimal is right there, 23457.50. And the rate decimal, which is, once again, 3 numbers, 2 of which is behind the decimal point. 7 numbers. 1, 2, 3, 4, 5, 6, 7, 2 of which is behind the decimal point. So it corresponds perfectly to this table, but you have to make sure the table's already correct. Remember, if we, based off our drop table, if we drop the table later on, then the data that's in it will go away. We can continue. In this particular case, now we've inserted a row into rep table, right? Only giving it the 3 values that are required: the number, the name, the rep number, and the name. So this inserts successfully because those are not null. And then we come along. It says using select command, we can select star from followed by name of the table. So I can do, I'm working with my table. I'm going to do select stars from rep table. So I'm going to select everything from the rep table, and it's going to display everything that's been entered into the rep table. So in this particular case, these are all the items that are entered in the rep table. So I went through the process of creating the rep table. Now I went through the process of entering data into the rep table. Now I'm going and actually looking at the rep table. Actually, I keep wanting to say reptile. Rep table actually with the values in it. And I can do, I could do SQL statements to draw it in a certain way. I can go through and make changes, update, delete, and insert. So I can update a certain one, update rep, select last name Perry, where rep number is equal to 75. So I'm going to set the last name equal to Perry, where this rep number is this. So I can go through and I can modify those values. I can correct errors, doing the same thing. Delete from rep, where rep number is 75, so I can delete that particular value if I want to delete it. So at any rate, that covers a lot of our SQL, some basic items. Hopefully that will help you out in Chapter 3. If you have any further questions, please address them to me directly. Otherwise, have a very good day, and we'll talk to you soon.